So for part 2, we're going to be looking first of all at example 3. It says, do not try to memorize the unit circle diagram. Instead, try to reason out the reference angle value by returning to the terminal side of the angle to the x-axis as quickly as possible. So what that's saying is that remember to find a reference angle, you have to go to the nearest x-axis. So let's look at 135. Okay, 135 would be over here in quadrant 2. So if I'm looking for the reference angle, that's going to be from the terminal arm to the nearest x-axis. Remember that that x-axis is 180 degrees right there. So how many degrees are between 135 and 180? 45. So we say that the reference angle is 45 degrees. So remember that theta with that little r stands for reference angle. Let's try B here. B is 240. 240 would be down here in quadrant 3. So again, I'm going to the nearest x-axis. So I'm looking for this part here again, going to 180. So between 240 and 180 is how many degrees? 60, right? So we say here that the reference angle is 60 degrees. Last one, 330 degrees is down here in quadrant 4. So that's 330 degrees. So now to the nearest x-axis would be looking at the distance between 330 and 360. So how many degrees reference angle between 330 and 360? 30 degrees, right? Good. So that would be how you find a reference angle. Now reference angles are very important because remember that reference angles share the same coordinate, just that the signs are going to be different. Alright, so it says here that a unit circle helps us to find the exact values of the trig functions for the quadrant angles for all of our nice angles. So 0, 90, 180, 270, 30, 45, 60, and so on. Remember also that reference angles will share the same coordinates, or the same sine and cosine values, just with different signs. So let's look first of all at sine 0. So sine 0, if you look to your unit circle, remember that sine is the y value. So I look at 0 degrees, sine at 0 is 0. So we'd say sine at 0 is 0 just from looking on your unit circle. Let's look then for cos at pi, cosine at pi. So pi is right here. Okay, so cosine is the first part of the x coordinate. So that means that cosine is negative 1. So we just say here, our answer is negative 1. Cosine at pi is negative 1. Let's look then to tan 45. Now tan is a little bit trickier. At 45 degrees here, tan is sine divided by cos, because it's opposite over adjacent. That puts sine, y over x. So at this 45 degree angle, that gives us root 2 over 2 divided by root 2 over 2. So let's put that in here. So root 2 over 2 divided by root 2 over 2. But what is anything divided by itself? 1, right. So this just gives us 1 because it's the same top and the same bottom. Good. One more, sine 4 pi over 3. So I'm going to look on here. 4 pi over 3 is down here. And I'm looking at sine. So sine is negative root 3 over 2. So we just say that it's negative root 3 over 2. And that would be it. Alright, so just try cosine and tan on your own, and we're going to jump to part G. Part G is cosecant at 3 pi over 2. So cosecant, remember that that's the reciprocal of sine. So if I go back and look at my unit circle, 3 pi over 2 is down here, and I'm looking down here, okay, sine is at negative 1. So if sine is at negative 1, I can say that sine of 3 pi over 2 is at negative 1, then cosecant is going to be the flip of negative 1. You're going to flip that value because we're talking about a reciprocal. So that means it'd be still negative 1. Because if I flip negative 1 over 1, okay, that would be like an invariant point. Remember when we discussed invariance? It doesn't change because it's still over 1. Let's try one that does change. Okay, so secant at 4 pi over 3. So let's start by looking for 4 pi over 3. 4 pi over 3 is right down here. And we're dealing with cosine, yes. So cosine is negative 1 over 2. So let's first find cosine at 4 pi over 3. And that's negative 1 over 2. So secant is going to be the flip of that. So when you flip negative 1 over 2, you get negative 2 over 1. Okay, so again, you just flip the reciprocal. Let's look at cotan of 5 pi over 6. Now lucky us, we already went over here and found tan at 5 pi over 6. So we can then find cotan 5 pi over 6. But remember, don't take the final product because we already multiplied that root out. Let's take an easier one. So let's take this part. We said that tan at 5 pi over 6 was 1 over negative root 3. So if I flip that, we get negative root 3 over 1. Just flipping it to find the reciprocal. Okay, now one more, cotan at 3 pi over 2. Remember that tan is y over x. So that would make cotan x over y, right? Because if you flip it, that's talking about your reciprocal. So we're going to find cotan of x over y at 3 pi over 2. So looking at my circle, 3 pi over 2, the x is 0, and the y is negative 1. So I'm going to go x over y, so it's going to be 0 over negative 1, and 0 on top just gives us 0. Alright, so now example 5, we're looking to find the exact angle this time. There's a few important pieces of information. First one is the domain we're looking at. So here it tells us our domain is between pi over 2 and pi. So if you think of where pi over 2 is, and pi, that means we're looking here in quadrant 2. So our answer is somewhere in quadrant 2. We're finding the angle where sine is root 3 over 2. So when I look here, sine, remember sine is y. So I see that sine is root 3 over 2 right there. And again, the question is going to tell you if you want radians or degrees based on the domain. So here my domain is in radians, which means your answer also needs to be in radians. So I look at this, the radian measure was 2 pi over 3. So my answer for this is that theta equals 2 pi over 3. So the angle is 2 pi over 3, where sine is root 3 over 2. Let's try the next one.
So we just figure out what quadrant it's in and then take the degree or whatever.
Yes. Yep. So now let's take here, the next one is located between 180 and 270. So 180 is here, 270 is here, which means we're dealing in quadrant 3. We're looking where cos is negative 1 over 2. So let's look here. Negative 1 over 2 for cos is right here. And the degrees on that is a 240 degree angle. So all we have to say is that theta equals 240 degrees. So it's somewhere in quadrant 3. Let's try then C. Here's C.
How come we said the
So let's look then and just compare your answers for part C and part D. Again, just looking at the quadrant and determining the angle for each one. All right, for example 6, we're getting onto calculator work. We know it's calculator work because it says determine values to 4 decimal places. So anytime we're talking about doing decimal places, we know we're using our calculators. The big thing is that your calculator will need to be in either radians or degrees based on the angle that you're given. So the first one here, it is 73 degrees. So all we're doing on our calculators is typing in sine 73. And your calculator has to be in degrees. Alright, so once you've typed it in, again, just check your radians or degrees. You should get the following answers. So try that and make sure you do. So the next one we're finding cosecant, secant, and cotan. So to find cosecant, what we need to first do is find sine. And then remember that cosecant is 1 over sine. So we'll basically put our answer for sine in the denominator and calculate it. Also, please remember that what this means is now that 3.0716 is the hypotenuse compared to the opposite. So now, again, we're getting numbers bigger than 1 because your hypotenuse is going to be larger than your opposite side length. Let's try the next one. So you can check your answers for the other two on the board. Let's look then to example 8. Example 8 is determining the value of theta in each of the following. So be careful here. Now we're going backwards. You also need to make sure you're in either radian or degrees based on your domain. So here the domain is in radians, so my answer and your calculator need to be in radians. So if I'm calculating sine theta equals 0.2357 and I want theta, how do you move sine over?
Subtract it?
No. Inverse. You inverse it, right. So remember that there's a button that looks like this, sine inverse. So what you need to do in radians is make sure sine inverse is 0.2357, and that will give us our reference angle. So this always gives us the reference angle. So what is my reference angle here?
2.2380.
Yeah. 0.2379.
79, I guess.
Were we supposed to be in radians?
Yes, 0.2379. So you guys, this again is the reference angle. Now you have to do a little bit of work because you have to find what the actual angle is. So this question tells us that we're working in quadrant 1. Oops, quadrant 1, okay? And that the reference angle is 0.2379. So I need to state then what the actual angle is.
Well, it's going to be that.
It will be the same, right, because it's in quadrant 1. So again, what you're given here is always the reference angle, and you have to calculate the angle in standard position. Let's try another one. So you can take a look at part B. It was very similar. Now let's look to C. So C is tan is 2.4071, and it's between pi and 3 pi over 2. So I'm looking down here in quadrant 3. So to find tan, and again it's in radians, make sure your calculator is set to radians. I'm going to need to inverse tan to the other side. And again, in radians, make this calculation. That's going to give me the reference angle. So here the reference angle should be about 1.177 radians. Okay. Now we have to, that's again down here. That's 1.177 radians right down there. I need to add on this top part to go all the way down to there. So we're in radians. So this time what do I add? Not 180 degrees. I have to add pi, right. So to find my actual angle, we have to go 1.77 and I have to add pi onto that. So just add with your pi button. So you should get 4.319, and that's radians. So in standard position, all the way around to that spot in quadrant 3, would be 4.319 radians. All right, so here we're looking for the angle, and the question is secant is 1.8933. It says it's between 3 pi over 2 and 2 pi, so we're looking down here in quadrant 4. Now, secant we can't calculate, but we can calculate cos. So we know that cos is the reciprocal of secant, which means I could go 1 over 1.8933. So I have to divide those two in order to get cos. So let's divide them. So once you go through and calculate your reference angle, then in this one, the reference angle is in quadrant 4. So we're going to have to take 2 pi and subtract your reference angle to get a standard position angle of 5.2688 radians. Let's take a look then at E. So you can take a minute then to finish the textbook questions that we didn't get to last day.